Alright, so this is just more examples of permutation cases, combination cases, and neither. I will do one set more of notes, sort of an extra set where I'm going to mix some together again, permutations, combinations, neither, focusing on groups, and then we're done with the lecture notes. Alright, so this example kind of looks at three cases that are very similar, but one of them is a permutation, one of them is a combination, and one of them is neither a permutation or combination. But the wording is very subtle, so it's very important that you read problems in this set very, very carefully. Right? What are they asking me for? What am I given? And what am I allowed? Right? A school offers 3 scholarships annually. Right? So they're giving away 3 scholarships. Suppose 100 people are eligible to receive, so 100 people can apply. All 3 scholarships are worth $5,000. How many ways can 3 different people be chosen to receive a scholarship? So how many ways can 3 different people be chosen by the school to receive a scholarship? Alright, so we have a total of 100 people. We're going to pick 3 to receive a scholarship. And then what counting technique do I use? Permutation, combination, or neither? Well, first of all, I need to pick 3 different people. That 3 different people means there is no repeats. Once you've been selected for a scholarship, you cannot receive a second scholarship, right? If you give it the same person twice, you don't have 3 different people. Right? So the 3 different people means no repeats. So now I'm down to permutation combination, right? No repeats. The second important thing is all of them have the same value. The first scholarship is $5,000. The second scholarship is $5,000. And the third scholarship is $5,000. So whether you're picked first, second, or third, you get $5,000 scholarship. So it doesn't matter to you what order you were picked in, just that you were picked. So no order of importance. Order doesn't matter because they're all the same value. The first scholarship is the same as the second scholarship as the third. They're all $5,000. Doesn't matter. If you're the third person, you get $5,000. If you're the first person, you get $5,000. So it doesn't matter to you what order you're picked in. You're all getting the same thing. So it's a combinations. Alright, which you have to use the combinations for. It's combination. Out of 10 people, I'm selecting 3. So it's a combination. Sorry, not 10 people. 100 people. Choose 3. So it's a combination 100. Choose 3. And again, you have to use the combinations formula in a combinations example. There's no other way to solve this. You can't list it. This is a fairly large set. All right, it actually comes out to 1,617,000. Or not, 1 too many zeros, sorry. So it's 161,700 different outcomes if they were just randomly selecting out, right? Which is a lot. You couldn't list that. It wouldn't be very easy to list. Right? Combination, and the big thing about the combination, 3 different people, that's the important phrase, and they all are worth the same amount. So it doesn't matter what order you're picked on, it just matters that you're part of the group of 3 that were selected. Alright, next example, same scholarships, same set of people, so I'm still offering 3, so I'm still going to pick 3 people. There's still 100 people to choose from, except this time, the 3 scholarships have different value. They're worth $5,000. They're worth $5,000, $2,000, $1,000 each. How many ways can the 3 scholarships go to 3 different people? Alright, so in this particular example, I still have a total of 100 people that I'm picking from. I'm still going to pick 3 of them. But this time, the first person gets 5,000, the second person gets 2,000, and the third person gets 1,000. So now it matters. Right? You still want to receive a scholarship, so you want to be part of the 3, but now it matters to you. There's a rank to it. There's an order of importance, right? You want to be picked first over being picked third, right? It matters. It's a $4,000 difference. And so this time, order is important because there's a different value to each pick. Right? The first person's value is 5,000, the second person's value is 2,000, and the third person's value is 1,000. And we're still giving it away to 3 different people, so that we're still not allowed repeats. Alright, so no repeats. Order is important, which means it's a permutation. Alright, so it's a permutation. Out of 100 people, I'm going to select 3. So if you're typing that on your calculator, it's 100 permutation. Choose 3. Which again is a really big number. Alright, this would be very hard to list. It comes out 970,200. Alright, now there is an alternative to the permutation. Remember, combination, you have to use the combination formula. Permutation, you don't have to. I could have solved this a different way. I could have given out, so this would be the 500, and this would be the 5,000, 2,000, and the 1,000, which means the first set of people, there would have been 100 that I could give away the $5,000 scholarship to. I've already picked one person, which means there would have been 99 left for the 2,000. Which means after I've done that, there should be 98 left for the 1,000. And I'm giving away all 3, so it's an and. I picked the first and the second and the third scholarship. If you take 100 times 99 times 98, that will come out to the same value as the permutation formula gave me. That's just an alternative. You can solve it that way if you want to. And that'll actually help you out for the next problem. Alright, so again, same thing. I'm giving away 3 scholarships to 100 people. The 3 scholarships have different value of 5,000, 2,000, 1,000 each. How many ways can the scholarships be awarded if they can go to the same person? So what that means is, technically speaking, you could pull out the same name all 3 times, meaning somebody could win all 3 scholarships, or somebody could win 2 of the 3, or 1 of the 3. Alright, so this means as soon as they say this, we're allowing repeats, allowing the same person to be picked again if we so choose. And so this is the neither case. It's neither a permutation nor a combination. It's just a straight multiplication. I have my 3 scholarships, so this would be the $5,000 scholarship, this would be the $2,000 scholarship, this would be the $1,000 scholarship. There were 100 people I could choose for the first one. Since I'm allowed to repeat, that same name could show up in the second one, so there's still 100 for those, and that same name could show up for the third one, and so there's still 100 in those. So I can give 100 away. 100 people could get the first one, and 100 people can get the second one, and 100 people can get the third, because of the repeats. Alright, which again, if you write that shorthand, that would be 100 cubed, or all written out 1 million. Alright, 1 million ways if I'm allowing repeats. Alright, if I'm allowed to give away to the same person. Alright, so the same person could win all 3. And so, like I said, these 3 examples are a good way to distinguish between combinations. The value's the same. Doesn't matter if you're first, second, third, or fifth. No repeats. Value's different. Order's important. Still no repeats. Alright, value's different, but we're allowed repeats. So, again, 100 people for each one. Alright, the last example for this set of notes, and then there's a couple problems for you to try on your own. Right? Out of 10 possible singers, you're to select 3 singers to do 3 different solo roles, and 4 of them to form a chorus. How many different ways are there to do? So this is actually, again, like, this is a toughie. This is this is one of those hard problems, because there are 2 counting techniques I'm going to use. Alright, we have 10 singers. 3 are going to perform solo roles. 4 are going to form a chorus. Alright, so when you're doing solo roles, I mean, you get to pick a part of the song where you get to sing all by yourself. Alright, the solo roles are different. You're not necessarily singing the same part in the song or in the presentation. And so it might matter to you which song you're doing solo to. And so for the solo roles, order matters. It matters what order you're selected to do the solo role in. However, if you're in a chorus, you're all singing together at the same time, the same words. And so the chorus, it doesn't matter whether you were picked first, second, third, or fourth. You're all singing the same set. And so this is actually a permutation and combination example. Alright, I've got to pick the 3 soloists. In the solo roles, order matters, because what song I'm soloing would matter. And I'm picking 3 singers, which means I'm picking 3 different people. Alright, I've got 3 solo roles to fill with 3 singers. So again, order matters because the solo roles are different. Right, one might be shorter than the other, right? So there's a difference between the solo roles. It'd be kind of like if you're auditioning in a drama, there might be 3 main characters, and then the rest are extras. Same idea. The 3 main characters, it matters which main character you are, but the extras are just extras. Right? So it doesn't matter, you're just an extra. Of course, it might matter a little more in that case. Alright. So the 3 solo roles, order matters, and no repeats. Permutation the case. After I pick the 3 solo roles, alright, you're going to pick 4 others, so other meaning other than the people in the solo, so other, so no repeats again, to form a chorus. Alright, so you're going to pick 4 others, again there will be no repeats. So if you're a solo role, you can't be in the chorus, and you want 4 chorus people, so you can't repeat people, otherwise you won't get 4 people in the chorus. Alright, so no repeats, you pick 4 others to form a chorus. In the chorus, order is not important. Because if you're in the chorus, you're all singing this together. Alright, it's like the group of marbles, you're all together. So order is not important, so this is a combination type. Alright, so I've got a permutation for the solo roles and a combination for the chorus roles. And again, no repeats. Since this is a hard one, I start out with 10. Alright, whenever you're selecting, you're always going to select your soloist first. Typically, it's your best singers, but suppose they're all pretty decent singers, and so you're going to do it randomly. You're just going to randomly pick 3 people to fill in the solo roles. And so when I pick the solo roles first, this is what I do first, is the solo roles. It's my permutation. I had 10 singers to fill in my 3 solo roles. However, I've picked them, and now I'm moving on. Well, then there comes the chorus, and the chorus is the others. I've already picked these 3. I can't pick them again. They're soloists. They're not going to be in the chorus. And so there's only 7 left for the others, right? 7 others. And so for the chorus, there are 7 left over to pick 4 of those to fill out the chorus. So out of the 7 people who didn't get the solo roles, I'm going to choose 4 of them to complete my chorus. Alright, so this is an example of a permutation. And these are rare examples, but I wanted to do one because it's a hard case. I just wanted to do one to show you that you could. You can have a case where you have both permutation and combination combined together. Alright, then you type it in the calculator, permutation 10 choose 3. If you type that on the calculator, that comes out to 720 times combination 7 choose 4, which is 35. Alright, so 120 times 35 comes out to 25,200 different ways to do this. Alright, so there are 25,200 different ways to pick 3 solo artists, 4 chorus artists out of 10 possible singers. Alright, next couple examples are on your own, so I'm going to let you try these on your own. So it's basically just the different cases. The first one, order matters. The second one, order doesn't matter. So one of them is a permutation types, one of them is a combinations. And again, I'll post the answers later on in the lessons on ReggieNet. Alright, so that finishes up. So basically we've kind of gone through all the types. So the biggest thing is we've now talked about everything in Chapter 6. So the quiz will be coming up over Chapter 6. So make sure you go back over any videos you found difficult. Try the practice problems, make sure you do the extra practice, the practice exam that are all posted on ReggieNet. Alright, and make sure you're starting to study and get ready. If there's a particular concept that you have trouble with, go back and rewatch those videos. Now, I am still going to have one more video from Chapter 6. I'm going to do one more set of notes that are kind of do groups again, because students tend to have trouble with those, where I'm going to mix combinations, permutations, cases. But pretty much right here we've done everything. We've covered everything. Like I said, I'll do one more video that will be an extra video covering groups of people. Alright, well, we'll stop there.